Hey everybody, let's take this 2D shape of a goblet drawn using functions in Desmos. So these are the functions. Let's revolve it around its central axis to make a volume and then compute that volume. So one way to do that is to integrate. So as an example, see this curvy part here in the green? This is it right here, right? Because imagine you split this into kind of like a stack of coins, where one of the horizontal disks has an area, pi times the radius squared. So for the green part, the radius is x equals y minus 1 quantity squared. So pi times this squared would be the area, and then the height would be infinitesimally thin, dy. So the volume of that disk would be pi times the radius squared times dy. And then you integrate from here to here, 1.25 to 2. And we're expecting a volume of 0.6277 for just this part right here. So let's try this using CAD. So let's switch over. Okay, so I'm using Autodesk Fusion 360, which doesn't have a built-in kind of equation editor. So I added this plugin here, this equation-driven curve plugin, which I'll put the link in the description below. But there's some details we need to watch out. So for one, it assumes your document is in centimeters. So let's just change it to centimeters. And the second thing, which I will demonstrate here, okay, so we want to make that equation y minus 1, x equals y minus 1 squared. Okay, so x, so y is the same as t, the parameter, and then x is y minus 1 squared from 1.25 to 2. Okay, so there's our curve. But see, if I like grab the end, see it moves. We undo that. So here. So as soon as I touch it, it kind of moves. Even if I try and add something to the end, see like right here, watch what happens to the curvy part in 3, 2, 1. There. See, it changes. It's because it's trying to like compute the spline to the next line here. Ready? 3, 2, 1. So we don't want that. So all we need to do is fix it. So just click on it, right click, and then it says fix. So now like we can't mess with it. Okay, let's draw the rest of the goblet. Okay, there's the stem part and then the foot. That's really not at all to scale, but we'll fix that later. Okay, so there, basically that's what it looks like. Let's dimension it. This bottom part was 1. This top part was 1. This height over here was 2. The foot was the blue line, 0.1. Okay, so this is 0.1. All right, there we go. So all we need to do is take this shape and revolve it around the central axis. And then we have a 3D volume. Just like this. Okay, but let's check the answer for only this curvy part right here. We expected a volume of 0.6277. So let me backtrack a little bit, and I'm just going to separate this curvy part. Actually, I need to separate it, so I'm just going to draw a line to separate that section right here. Here. Okay, so now let's only look at this curvy part. So let's revolve it around the central axis, and we have this shape. This shape. All right, so what's the volume? We're expecting 0.6, I already forgot, 277. All right, So at the click of a button, 3, 2, 1, go. 0.628 right here, the volume. All right, so that checks out. Okay, thanks for watching the video. I'll see you on the next one.